Hi everyone, this is the first video in Unit 4. In this unit we'll be talking about everything quadratic. Quadratic functions, graphing, analyzing, factoring, you name it, we're going to do it in this unit. A quadratic function, as you recall, is going to yield a parabola. Its general form looks like this, where ax squared, that 2 should be moved over a little, plus bx plus c, and a does not equal 0. A, b, and c are coefficients. There has to be an x squared term or it's not quadratic. So, sorry about this. This little 2 got in the wrong spot. It should be here. So if we're doing y equals x squared, if we put in 0 for x, then y is going to, 0 squared is just 0. If we put in a 1 for x, 1 squared is 1, so over 1 up 1. And if we put a 2 in for x, 2 squared is 4. So this is 1/2 of the parabola. The cool thing about parabolas is that they're symmetric. So if we just go over 1 up 1 the other side, over 2 up 4 the other side, we get the other half of the parabola. So because it's symmetric, it's going to have an axis of symmetry, and that's the line that it is the same. You know, if I cut that right down the middle, if I graphed it perfectly, it would look the same on the right and the left. So the axis of symmetry is going to go through the x equals 0. The axis is a line. So this is an equation of a line. The vertex of a parabola is either the lowest or the highest point. Of x squared, it would just be 0, 0. But the vertex is either going to be the maximum point. If I had a parabola that looked like that, the vertex would be the maximum. Or on this one, it would be the minimum point. Okay, I want you to also notice that the axis of symmetry goes through the vertex every time. So wherever the vertex is, since the vertex is at 0, 0, the axis of symmetry is going to go through the y-coordinate of that, and the x-coordinate, so x will equal 0. It will be the x value. Here's another graph of a different parabola. You'll notice that the parabola has been moved from the normal position. You know, the vertex of y equals x squared, the vertex was at 0, 0. Well, now the vertex is at 2, negative 2, because the graph of x squared has been moved right 2 and down 2 from its original. So you can see that the y-intercept and the vertex are not always the same thing. In fact, the y-intercept on this graph is 0, 2. The axis of symmetry, I'll get to in a second, the vertex is 2, negative 2. The axis of symmetry is going to pass through the vertex, so that's going to be the line x equals 2. Notice that the axis of symmetry is a line, but it's not a function because it's straight up and down, vertical. The vertex is a minimum because it is the lowest point on the graph. This is the concept summary. This has got it all together. So if you have the equation of a quadratic function written in standard form, and standard form is that ax squared plus bx plus c, then there are certain things that you can get from the equation, and one of them is the y-intercept. Recall that the y-intercept is where you let x be 0. So the y, 0b or whatever. So if you put a 0 into this equation, you would have ax, or a0 squared plus b times 0, which both of those go to 0, and you end up with c. So the y-intercept is going to be 0c, or that last coefficient. The other thing that you need to write down is that the vertex of an equation written in standard form, the x-coordinate is negative b, the b coefficient, over 2a. And then to find the y-coordinate, you just plug that in. Basically, that's what this notation means, is that whatever you find for x, put that back into the equation and solve for y. All right? So you can see here that the axis of symmetry is just going to be x equals the x coordinate. You've got a reflection, right, over and then wherever the vertex is. So write this down, and then we're going to use it here to do some examples. Okay, so here I have this quadratic function. I have f of x is equal to x squared minus 4x plus 2. And I need to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. All right, so first of all, let's remember that the y-intercept is the point 0 something. Okay, so I'm going to put in 0, right? That's the easiest. 0 squared minus 0 plus 2. So this is 2. Done. Now, to find the x-coordinate, I'm going to do negative b over 2a. And so before that, I'm going to write out my coordinates. So I have coefficients. So a is equal to the coefficient in front of x squared, which is 1. B is the coefficient in front of the x term, and c is the other one, 2. So I have negative b over 2 times a, which is 4 over 2, which is 2. So my x-coordinate of the vertex is 2. And I could quite easily find the y-coordinate because all I'd have to do is put it back in. And that is 4 plus 2 is 6, so this would be negative 2. That's my vertex. And then the equation of the axis of symmetry is always going to pass through the x-coordinate, so it's going to be x equals 2. So those are the 3 things I needed to find just from the equation. You don't have to write this one down, but let's take a look at this for a second. It says, where is the vertex of this graph from the table? Okay. So here are my points. This is, what they did is here's my equation, right? I put in 0, and I got 2. So this is the y-intercept. Okay. If I put in 1, I got negative 1. That's y-coordinate. 2, I put in 2, I got negative 2. 3, I got negative 1. And 4, I got 4, 2. So if you'll think about this a second, what you're doing, all the x-coordinates are just in order, right? They start with 0, 1, 2, 3, 4. So what we're really looking at are the y-coordinates. And you can see here it starts at 2, then it goes down to negative 1, then negative 2, then negative 1, and then back up to 2. So you can see that the lowest point, it goes down and then back up again, right? So it's doing this parabola thing. So this right here is going to be the vertex. And then notice the symmetry with the y-coordinates. So these are both 2, these are both negative 1. So from a table, you can actually look and find the vertex. Here's another concept summary. A maximum and minimum value. It says when a is positive, the coefficient in front of the x squared, when it's positive, then you're going to have a parabola that turns up, and this is going to be a minimum. If a is negative, then it's going to go down, going to face down like this, and this top point is going to be a maximum. The y-coordinate is the min and maximum. So it's the y-coordinate of the vertex, and that's of the vertex. This is really important. Make sure you get this in your notes. Okay, so does the function f of x equals 3x squared plus 6x have a max or a min value? Well, we look at a, and a is positive, so this one is going to have a minimum. Okay, we're going to find the equation of the axis of symmetry. We need the x-coordinate of the vertex and the y-intercept. The y-intercept is going to be where x is 0, which will just be 0, 0, be the origin. Okay, and I need the x-coordinate of the vertex. So a is 3, and b is 6. So negative b over 2a, so that's negative 1. So the axis of symmetry is going to be x equals negative 1. And now I need the, so I know this is going to be the axis of symmetry, right? It's going to pass through here. The x-coordinate of the vertex is at negative 1. If I put negative 1 in there, I'm going to get 3 times negative 1 squared, so that's just going to be 3, plus 6 times negative 1, so that's negative 6, so negative 3, which of course is off my grid here. It's awesome. 1, 2, 3. So it's going to be here. I don't know if it'll let me write there or not. Well, it's down here, clear down here, which I can't get it to write, so I'll do this one. And I know it's symmetrical, so it's going to go something like that. There. Well, that worked, so I don't know why it didn't do the other way. And going to go up, and that's what that looks like. All right, so there were quite a bit of notes here, but we're going to talk more about this in class. So make sure that your notes are complete, rewatch anything you need to, and I will see you in class. Okay, what I'd like for you to do is I would like for you to do this problem in your composition notebook, and then remind me when you come to class and we will go over it. All right, see you in class.